All right, 11.3 is going to look more at solving quadratic equations. All right, quadratic equations have either 0, 1, or 2 solutions. They are considered your x-intercepts. So when the equation equals something, if you set it equal to 0, the x-intercepts are your solutions. 0 solutions means the graph is either above or below the x-axis. 1 solution is the graph sits right on the x-axis, so the vertex is your x-intercept. And then 2 solutions is when it crosses through the x-axis. So any of those are possible. All right, solve, support numerically and graphically. So to solve this first one, we only have an x, so we're going to move numbers to get it alone. I'm going to subtract 1 from both sides. I'm going to divide by 2. And then to undo a squared, we take the square root. And you cannot take the square root of a negative, so there's no solution. If I were to graph this, the graph's going to look like this. And doesn't cross the x-axis, so there's no solution. All right, let's look at this one. Here we have an x squared and an x. So we need to get everything on the same side so that it equals 0. Subtract 4x from both sides. So we have x squared minus 4x plus 4 equals 0. Now we can factor. So we have a times c. Factors that multiply to get 4 and add to get negative 4. Greatest common factor. Multiply across. We have x minus 2, x minus 2. To solve that, we make it equal 0. Add 2 to both sides, we get x equals 2, and they're the same, so we only have one solution. If I were to graph this, it would look like this. So if we were to type it in the calculator, that's what we would get. And in fact, there's only one solution where it touches the x-axis. All right, let's look at this last one. We already have the 3 terms, so let's tic-tac-toe. A times c. Factors that work. Multiply up, multiply across. We get x minus 4, x minus 2. Make each of those equal 0. We get x equals 4. And we get x equals 2. So those would be our 2 solutions. If I were to graph this, it would look like that, showing us that there are, in fact, 2 solutions, and that's what they are. So I'm just going to put those in the calculator really quick, in case, just to make sure. This first one, 2x squared plus 1. Then we have x squared minus 4x plus 4. And then we had x squared minus 6x plus 8. If we graph those 3, the blue doesn't touch, the red's right on, and the black's below. So you can graph them by hand if you want. You can graph that on a calculator and take a picture, whatever works for you. All right, real life. So if we're throwing a ball, we're standing here. Here's somebody. Here's the ball. When you throw it, it goes up and comes back down. So our maximum is going to be the vertex. To find the vertex, we do h comma k. So opposite of b over 2a. So negative 48 divided by negative 32 is 1.5. Then we plug that in for t. And we would get 40. So the max height is 40 feet at 1.5 seconds. Then we want to know, when will it be 24 feet? So at some point, the ball is going to be 24 feet. So I'm just going to redraw this a little bit. So we have a person here throwing the ball. He throws it really high. Our y-intercept, our initial value is 4. We just said this is 40 feet. and it's at 1.5 seconds. We want to know when it hits 24. So 24 is going to be somewhere in here. It hits it at 2 different places. So we should expect 2 answers to be 24 feet on the way up and on the way down. So we're going to plug that in for the height. 24 equals negative 16 squared t squared plus 48t plus 4. To solve a quadratic, we need to make it equal 0. So we subtract 24 from both sides. If I take out a greatest common factor, everything's divisible by negative 4. So I'm left with 4t squared minus 12t plus 5. If I tic-tac-toed this, I would do a times c. Negative 10 times negative 2 works. Greatest common factor, multiply up, multiply across. We have 2x minus 1, 2x minus 5. If I made those equal 0, this would end up being 1/2. And this would end up being 5 halves, which is 2.5. So at a ½ second it hits, and at 2.5 seconds it hits on the way back down. Now the next question is, when will it hit 50 feet? You may look at this and go, okay, well, I'm going to do the same thing. 50 equals negative 16t squared plus 48t plus 4. Subtract 50 from both sides. You get minus 46. Take out a greatest common factor. You find out it can't be factored. If you put it into the quadratic formula, you would get no solution. No solution. You also may have said, well, we just said the max was 40 feet. If the max is 40, it's never going to hit 50. So you might be able to see it right away. Sometimes you don't necessarily have to do all the math out. All right, if you see solve at this point, from here on out, solve means find all solutions. That means real. That means complex. That means positive and negative, all solutions. So here where it says solve for all solutions, now we're going to take the square root. But remember, square roots are positive and negative, so you have to account for both. The first test, we talked about that. The second test, it didn't matter as much. This test, if it says all solutions, the positive and the negative matter. Here we just have the x, so I'm going to move the 9. Divide both sides by 16. X squared equals 9 over 16. Take the square root to get the x alone. Square root of 9 is 3. Square root of 16 is 4. Don't forget the positive and the negative. When you have one like this, it already has the squared by itself, so we have to take the square root before we can do anything. When we take the square root of what's in the parentheses, it just stays what it is. The square root of 25, that's where we see our positive and our negative. Now we can solve this to get our 2 solutions. One is 9. One is negative 1. Those are the 2 solutions. All right, a toy falls from a window that is 30 feet above the ground. How long does it take for the toy to hit the ground? We're given an equation. Well, hitting the ground, if we go back up here, that's going to be our x-intercept, if you think about this like a graph. So we want to solve when it equals 0, when the distance from the ground is 0. So I would subtract 30 from both sides. Divide by negative 16. And I get 1.875 equals t squared. And then we take a square root of that, which when we're talking real life, we kind of want an answer. So I'm going to get positive or negative 1.37 seconds. Now, can you go back in time? No. So the only answer that matters here is the positive. So in real life, you may ignore the negative. I know it can get confusing, but hopefully real life, only positive. If it says all, just write everything. All right, so we kind of looked at this way back a while ago. Solve for a variable. That just means rearrange the equation so that it says that letter equals. Now we're going to add some squareds in there. So the first one, v equals 1/3 pi r squared. We want to solve for r. So 1/3 pi, we want to get that away from the r. So to undo the multiplication, we're going to divide by 1/3 pi. When you divide by a third, it's like multiplying. So really, we're going to have 3v over pi equals r squared. So let me show you. V divided by 1/3 pi is like saying pi over 3, because 1/3 times pi would be pi over 3. When you divide, you change it to multiplying and flip. So that's where the 3v over pi comes from. Now we have a squared, so we take the square root of both sides. Remembering we need a positive and a negative. At least until we know what we're talking about, we need the positive and the negative. All right, this one we want to solve for t. So first we need to get the term with the t alone. So we have s minus h equals -1/2 gt squared. If I want to get the 2 off the bottom, I can multiply both sides by 2. Now we're going to divide by the -1g. So 2 over s minus h, or 2 times s minus h over -g equals t squared. To get rid of the squared, we do our plus minus and the square root. Now here, I did these 2 steps separate, but it was the same step that I did here. I was just showing you another way to move that fraction. You can do the denominator and then the numerator, or you can do it all at once. You end up with the same answer. All right, let's do this last one. Subtract x squared to get the y alone. So we have d squared minus x squared equals y squared. To get rid of a squared, we do our square root, and we need a positive and a negative. That's the biggest part on these. Using all of that information, see if you can solve this problem. So I'm going to divide by 1/2, which is like multiplying by 2. Undo a squared by taking the square root. Now, depending on what the question asks, we could simplify this. Plus minus. 1,300 is like saying 100 times 13. The square root of 100 is 10 with the root 13 after it. So if we need exact, that's our exact simplified. If we don't need exact, we can just plug this right in the calculator and we would get 36.06. So it just depends on what it's asking. But that is 11.3. Let me know if you have any questions.